When we talk about squares and square roots, we want to remember that squaring is slightly different than multiplication. And the difference is similar to the fact that we can repeatedly add to do multiplication, but we don't say that multiplication and addition are the same thing. So similarly, although we can multiply to get squares, squaring and multiplication are not the same thing. So with squares and square roots, we want to make sure that we have a model for this. And the model that we use is when we square a number, we're taking a square shape, we're taking the side length and finding area. And square rooting would then be the opposite. We start with the square area and square rooting gives us side length. So when we square something, so going left to right, we're starting with side length. Okay, so the x in this case, when we square something, the x represents the side length, okay, and the answer or output represents the area. If I'm going in this direction, the x in this case, what I square root is the area, and the output or my answer becomes the side length. So I square root area, I get side length. So squaring represents area, square rooting represents side length. So when we are squaring and square rooting, it's important to recognize which parts represent the side length and which parts represent the area. So when we talk about the side length, square rooting is a side length, but the inside, what we're square rooting, is area. So when I see this statement, square root 89, the area is 89 units squared. The side length works out to be square root 89. Okay, and the decimal value for that is going to be our side length. Here in this picture, we have 8 squared. Well, squaring gives us area, so the answer to this, 64, represents area of 64. That means that 8, not 8 squared, 8 squared is the area. The side length then is 8. So when we see these statements, the inside represents area, the answer represents side length. Here, the inside of the square represents side length, the answer represents area. So if I have an area of 33 squares, to get the side length, I need to square root. Okay, if I have the side length of 12, to get the area, I need to square. So to do this, I'm going to need my calculator since these are not perfect squares. So square root of 33, going to my calculator, I get a value of 5.7445. So I'm going to round that. So if I want to express this as an exact value, square root 33, when I do the square root, I'm getting side length. Although I see the area, this expression represents side length. And this is approximately equal to 5.74 when I round that. If I have the side length of 12, well, I'm going to square it to get the number of squares. And this represents the area. So I have an edge length of 12. My area is 144 squares, or I could also write this as 12 squared. Okay, these are equivalent. Okay, although I see the side length, this expression represents area.